Hello my dear students, myself Mahesh B. Koot. I welcome you to my channel Colorful Chemistry and Meaningful Mathematics. So today we are going to discuss the third part of differentiability chapter. So in that we are going to discuss the exercise 5.4 in NCERT problem solutions, right? So in this class we are going to discuss derivative of exponential and logarithmic functions. So in this session we are mainly focusing on the exercise 5.4. Every problem of 5.4 we are going to solve in this session. So before going to that, you know what are exponential functions, guys? So the exponential functions are nothing but the functions in the form of e raised to x, right? Functions in the form of e raised to x are exponential, and functions in the form of log. So whatever the logarithmic functions are there, so those functions, what is the derivative of those functions, we are going to discuss. So before wasting time, let us start with a exercise. Exercise 5.4. Okay, first problem is nothing but, so you are asked to find the derivative of e raised to x divided by sin x. This is the first problem we are given with. So carefully look at guys here. A by b, nothing but quotient rule we are going to apply here. Which rule? Quotient rule. What the quotient rule tells? Quotient rule tells about u by v whole dash, nothing but differentiation of two functions with the dividend. So denominator as it is d by dx of numerator minus numerator as it is d by dx of denominator divided by denominator square. So this is the formula. Denominator as it is d by dx of numerator minus numerator as it is d by dx of denominator divided by denominator square is a formula. So we have to apply the same formula. First write the given function as a y equal to e raised to x divided by sin x. So now differentiate dy by dx equal to, so what is the formula there? Denominator as it is. What is denominator here? Sin x. Sin x as it is. D by dx of e raised to x. So we know already differentiation of e raised to x is e raised to x itself. Next, minus is there, minus. Numerator as it is. E raised to x as it is. D by dx of sin x, nothing but it is cos x whole divided by denominator square. That means sin square x. So this is an answer. You can simplify again. E raised to x is a common here. Dy by dx. E raised to x is common. You can write sin x by sin square x. Sin x divided by sin square x minus, what is there? E raised to x already common taken. Cos x divided by sin x into sin x I will write. So sin square x can be written as sin x into sin x. Here 1 sin x get cancelled. Cos by sin, cot, 1 by sin, cosec. So 1 by sin, cosec. You can write e raised to x into cosec x, because 1 by sin x is there. 1 by sin is cosec minus cos by sin is cot into 1 by sin is cosec x. So here cosec x is also taken a common, dy by dx. So finally dy by dx equal to e raised to x cosec x 1 minus cot x. So this is a formula. Because cosec x is common again, we can take common outside. 1 minus cot x we are left with. So this is a quotient rule we have applied. And remember, differentiation of d by dx of e raised to x is always e raised to x itself. So that we have applied. First denominator as it is d by dx of numerator. E raised to x differentiation is e raised to x only. Minus numerator as it is d by dx of sin x is cos x, then denominator square. So by taking e raised to x common, we are left with sin x minus cos x divided by sin square. So I have splitted the whatever the minus sign there, sin x by sin square x minus cos x by sin square x. So I have written sin square x as a sin x and sin x, because cos by sin is cot, 1 by sin is cosec. So here sin get cancelled, 1 by sin is cosec. So common term is cosec, 1 minus cot is left here. So this is regarding the derivative of first example of this exercise. Now we will switch on to the second example. Now we are going to the second example, so which contains e raised to sine inverse x. Second one is e raised to sine inverse x. So whatever the given is there, you write that as a y equal to e raised to sine inverse x. So what we should do now, we should go for the differentiation of this. So dy by dx equal to e raised to x. Let us treat this sine inverse x as an x. So what is differentiation of e raised to x? E raised to x itself. So right, differentiation of e raised to sine inverse x is e raised to sine inverse x itself. But if x is there here only it will end. But here not is x. Here it is a sine inverse x. So we should do again d by dx of sine inverse x. Right. Then dy by dx equal to e raised to sine inverse x into differentiation of sine inverse x is 1 divided by square root of 1 minus x square. So totally we are getting e raised to sine inverse x divided by square root of 1 minus x square as a final answer for this. So I hope you understood. So another method is also there. The method 2 for this example, there is nothing but applying log. Method 2. So whatever given, y equal to e raised to sine inverse x. Apply log. Applying log. So log y equal to log of e raised to sine inverse x. Right. Now we know already the property of logarithmic function, sine inverse x into log e. This is because we have a formula log x raised to n is equal to n into log x. So whatever the power is there, that is multiplied front here. Look at here, e to the power is there, that is multiplied front. And log e value is 1. Log e value is always 1. So therefore now differentiate now. Log y differentiation is 1 by y into dy by dx. Sine inverse x is differentiation is 1 divided by square root of 1 minus x square. Already log e value is 1. Therefore this is only sine inverse x because log e is 1. So here dy by dx is there, 1 by y is there. You take this side, dy by dx equal to, here it is y is dividend side. When it comes this side, it becomes numerator. So y into 1 divided by square root of 1 minus x square. What is y here? Put here this value. E raised to sine inverse x divided by square root of 1 minus x square. So this is your dy by dx. So y is given here, this one. Same answer both sides. Here we applied a logarithmic function. Here we are differentiated directly. You can use any method. Both are same. So next example, e raised to x cube. Question number 3, e raised to x cube. So whatever the given function is there, let us treat as an y equal to e raised to x cube. Next, what we should do, differentiate this one, or else you can use a logarithmic, whatever, your choice. So I will directly differentiate dy by dx equal to, treat this as an x. Whatever the function is there above the e raised to e to the power, you have to choose that as a x, then go proceed. So differentiation of e raised to x is e raised to x only, but in place of x we are having x cube. If x is there, here only it will end, but it is x cube. Again we should take differentiation of x cube, right? So e raised to x cube into differentiation of x cube is, you know already, d by dx of, yes, d by dx of x raised to n is n into x raised to n minus 1. So what is n here? 3. 3 into x raised to 3 minus 1 means it becomes 2. So finally we are getting 3x square into e raised to x cube is an answer, dy by dx. So this is an answer for this question. So what we should do here, e raised to x cube is there, treat this x cube as an x, then e raised to x differentiation is e raised to x only, but in place of x, what we are having? X cube. So here x is there, here only it will ends, but it is not x. So we should again differentiate the x cube. So x cube differentiation is 3x square. Why this one? Because d by dx of x raised to n is n into x raised to n minus 1. Whatever power is there, you multiply here front, and one less than that number, you have to take the power. So this is a third example. Next, fourth example of this exercise. Sine of tan inverse e raised to minus x. Sine of tan inverse e raised to minus x. So this is a fourth example. So whatever the function is given, let us treat as an y equal to sine of tan inverse e raised to minus x. Now go on differentiating. Dy by dx equal to, so treat this function as an x. So sin x differentiation is cos x. So you write cos of x. In place of x, what we are having? Tan inverse of e raised to minus x. Right? If x is there here only it will ends, but here it not ends because it is a tan inverse e raised to x. Now again differentiation of this we have to take. D by dx of tan inverse e raised to minus x. Now this as it is cos of tan inverse e raised to minus x as it is. Now differentiation of tan inverse x. Treat this as an x. So tan inverse x differentiation is 1 divided by 1 plus x square. You write 1 divided by 1 plus, in place x square we have to take. In place of x square, what we are having? E raised to minus x square. Now if x is there, here only it will ends, but it is not x. So again we have to take d by dx of e raised to minus x. So this is according to chain rule. Next one, cos of tan inverse e raised to minus x into 1 divided by 1 plus, look at here, e raised to minus x square means it becomes e raised to minus 2x, because a raised to n raised to m is equal to a raised to nm. So that formula I have applied. D by dx of e raised to minus x. You know already, differentiation of e raised to x is e raised to x itself. So in place of x we are having minus x, e raised to minus x into x is there, here only it will ends, but it is not x. Again we should take differentiation of minus x. So what we are getting? Cos of tan inverse e raised to minus x into, this is there, everything is there here, multiplication sign, we can take divide also. This is 1 plus e raised to minus 2x into e raised to minus x into minus x differentiation is minus 1 into x differentiation is 1. So therefore we are getting minus 1. Right? So here is an answer for this, minus e raised to minus x into cos of tan inverse e raised to minus x whole divided by 1 plus e raised to minus 2x. So this is the answer for this question. Here it is a dy by dx. Same thing. I hope you understood what I did. So whatever the function is given, that I have taken as a y, then differentiated with respect to x, treating whatever the function as an x. So sin x differentiation is cos x, but in place of x we are having tan inverse e raised to minus x. So I have took that one. So if x is there, here only it will ends, but it is not x. It is a tan inverse e raised to minus x. Again we should take differentiation of tan inverse e raised to minus x. So differentiation of tan inverse e raised to minus x is, again we should treat whatever function is there, co-function, that as an x. So tan inverse x differentiation is 1 divided by 1 plus x square. So in place of x we are having e raised to minus x. 1 divided by 1 plus e raised to minus x square. If x is there, here only it will ends, but it is not x. It is e raised to minus x. Again we should take differentiation of e raised to minus x. Everything is same. So e raised to minus x differentiation is again e raised to minus x. But x is there, again here only ends. But it is not x. It is a minus x. Again we should take differentiation of minus x. So everything is same. So differentiation of minus x is 1. Everything is same, divide by. Simplify that one, you can get an easily answer. I hope you understood. Next example. Example number 5. Example number 5. Log of cos of e raised to x. So what is our aim? We have to find the derivative of this function. So to find the derivative of that function, first treat the given function as a y. So take this as a y. Y equal to log of cos of e raised to x. So now differentiate this one. Dy by dx equal to, treat this function as a x. Log x differentiation is dy by dx of log x is 1 by x. Log x is 1 by x. So treat this as a x. So differentiation of log x is 1 by x. In place of x, what we are having? Cos of e raised to x. If x is there, here only it will end, but it is not x. It is a cos x. So we should differentiate this cos of e raised to x. Now take this as it is, 1 divided by cos of e raised to x. Now differentiation of cos x. Treat this e raised to x as an x. Now differentiation of cos x is minus sin x. You write minus sin x. In place of x, what we are having? E raised to x. If x is there, here only it will end. But it is a e raised to x. Again we should take differentiation of e raised to x. So finally what we are getting? 1 divided by cos of e raised to x into minus sin of e raised to x into differentiation of e raised to x is e raised to x only. So sin by cos we are getting minus sin e raised to x divided by cos e raised to x into e raised to x we are getting. Sin by cos is tan minus tan e raised to x into e raised to x is the answer. Dy by dx equal to. So this is what regarding fifth example. Now we will switch on to the sixth one. I hope you understood. Sixth example. So e raised to x plus e raised to x square plus e raised to x cube plus e raised to x raised to 4 plus e raised to x raised to 5. So we are given with this function. So what is our aim? We have to find the derivative of this one. So treat the given function as a y. Y equal to e raised to x square, e raised to x cube, e raised to x raised to 4 plus e raised to x raised to 5. Now go on differentiating. That's it. Differentiation of y is dy by dx. Differentiation of e raised to x is e raised to x. Differentiation of e raised to x square is, plus sign is there, you write plus. E raised to x square differentiation is e raised to x square into differentiation of x square we have to take. Because x is there, here only it will end. Because of it is an x square, we have to again differentiate x square. Plus e raised to x cube differentiation is e raised to x cube into differentiation of x cube. Next, plus e raised to x raised to 4 differentiation is e raised to x raised to 4 into differentiation of x raised to 4. Last one, e raised to x raised to 5 into differentiation of x raised to 5. Because whatever the function is there, that we have to treat as a x. Then go for differentiation. If it is x, there only ends. But it is not x. Again d by dx of x square. D by dx of x cube, x raised to 4 and x raised to 5. I hope you understood. Now go on differentiating. Remaining same. E raised to x as it is. E raised to x square as it is. Differentiation of x square is, you know already, differentiation of x raised to n is n into x raised to n minus 1. So differentiation of x square is 2x we are having. Because 2 as it is, differentiation of 2 minus 1 is 1. So 2x we are getting. Similarly, e raised to x cube into differentiation of x cube is 3x square. Yes, e raised to x raised to 4. Differentiation of x raised to 4 is again x raised to n formula. So x raised to n means n into x raised to n minus 1. N is 4. 4 into x raised to 4 minus 1 means 3 we are getting. Plus e raised to x raised to 5. Next, x raised to 5 differentiation is 5x raised to 4. Right? Combining everything. So anything is common in this all thing? Nothing is common. So here is the answer for this question. Nothing but dy by dx equal. E raised to x raised to square is there. We can't take anything common outside. So this is question number 6. Now we will switch on to the question number 7. I hope you understood, because in between the two functions we are having addition sign. So whenever the addition sign is there or subtraction sign is there, we can differentiate separately, right? That is a property of derivatives. Next one, seventh example. Example number 7, square root of e raised to square root of x. So this they have given. This is a given function. So what is our aim? Our aim to find the derivative of this function. So treat the given function as a y. Y equal to square root of e raised to square root of x. Right. So now we have to differentiate that one. dy by dx equal to. Treat whatever the function inside the square root is there. Treat that function as a x. You know already, differentiation of, what is that? Differentiation of, here only I will write, d by dx of square root of x is nothing but 1 divided by 2 root x we are having. Yes, we are having the differentiation of d by dx root x is 1 divided by 2 root x. So what is x here? In place of x we are having e raised to root x. This is root x. Whatever the function inside the square root, we treat as a x. So differentiation of this one is 1 divided by 2 root x we are having. What is x here? E raised to root x we are having. Into differentiation of, yes, d by dx of e raised to root x. Next one, dy by dx equal to 1 divided by 2 root e raised to root x into d by dx of e raised to root x. Again we treat root x as a x. So differentiation of e raised to x is e raised to x only, but in place of x we are having root x. Now into differentiation of root x we have to take. Again what we are having? 1 divided by 2 root e raised to root x into e raised to root x as it is. Now differentiation of root x is 1 divided by 2 root x we are having. Carefully see here, 2 into 2, 4. So here also root is there, here also root is there. We can include this x inside the bracket. Yes. So remaining e raised to root x whole divided by 2 into 2, 4 square root of. So here e raised to root x is there, here x is there. We can write x into e raised to root x inside the square root. Because both are in the square root, we can include inside. So this is nothing but dy by dx, required answer. I hope you got the answer. So carefully see here, whatever the given function is there, I took that function as a y and treated the whatever inside the square root bracket is there. So I have treated this as an x. So square root of x differentiation is, we have already here square root of x 1 divided by 2 root x. So 1 divided by 2 root x. But in place of x what we are having? E raised to root x. I have taken e raised to root x. If here x is there, here only it will ends. But it is not x. So again we have to take a differentiation of this function. Again e raised to root x is there. The differentiation of e raised to root x is treat root x as an x. Again e raised to x differentiation is e raised to x into, if x is there, here only it will ends. But it is a root x. Again we have to take a differentiation of root x. Root x differentiation is 1 divided by 2 root x. Simplifying this, we are getting the answer. I hope you got the answer. Next one, 8th problem. Number 8. So given function is log of log x. Log of log x, where x is greater than 1. So this is the condition. Don't worry about the condition. Let write whatever the given function as a y. Y equal to log of log x. Now we have to differentiate. Differentiation of y with respect to x is dy by dx. Now what we should do? Whatever the function given in bracket, we should treat as a x and go on proceeding the differentiation. Log x, treat log x as a x. So differentiation of log x is 1 divided by x we are having. Right here, d by dx of log x we are having as a 1 by x. Remember this formula. Now, in place of x, what we are having? Log x. You write here log x. If x is there, here only it will ends. But it is not x. It is a log x. So again we have to take d by dx of log x. So dy by dx equal to 1 divided by log x as it is. Differentiation of log x is 1 by x. So simplifying these two terms, we are getting as a 1 divided by x into log x. So why I have taken 1 by log x? Because I treated this log x as an x. We just assumed. So log x differentiation is 1 by x. But in place of x, what we have assumed already? Log x. So I have put it here log x. So if x is there, here only it will end. But it is not a x. It is a log x. So again we have to differentiate log x. So differential of log x is 1 by x. Totally combined, this multiplication sign is there. We can write 1 divided by x log x. So this is a problem number 8. I hope you are getting. Next one, 9th problem. So 9th function we are given with cos x divided by log x. Cos x divided by log x. So here is the question number 9. So here we have to apply, here condition is x is greater than 0. Okay. So whatever the given function is there, we treat as a y equal to cos x divided by log x. Next, differentiation of this we have to do. So here the function, whatever present in the numerator is one function, whatever present in the denominator is one function. So we are applying this rule, nothing but quotient rule. Whenever two functions are on the numerator and denominator, we apply quotient rule. What is that? Denominator as it is, d by dx of numerator, minus numerator as it is, derivative of denominator, whole divided by denominator square. So what is numerator here? Cos x. What is denominator? Log x. So go on proceeding now. dy by dx. Which formula we used here? U by v rule. U by v whole dash equal to v, denominator as it is, derivative of numerator, minus the numerator as it is, derivative of denominator divided by denominator square. So this formula I use it here. Okay, so use this formula. Denominator as it is. So what is u as v as it is? V means here log x. So log x as it is. D by dx of cos x. So what is the differentiation of cos x? Minus sin x. Now minus numerator as it is, cos x as it is now. Denominator d by dx of log x is nothing but 1 by x whole divided by log x whole square. Just simplifying, what you are getting? Minus sin x into log x, minus sin x into log x, minus cos x divided by x whole divided by log x whole square. So we can simplify by taking minus sign common and multiplying x here and taking divided. So nothing but minus sign common, x is multiplied here, x into sin x into log x plus minus sign taken common here. So cos x as it is, taking LCM as an x. So divided by, that LCM comes here, x into log x whole square. So this is the answer for this question, dy by dx of the following function. I hope you got the point here. So we have used here quotient rule. Whatever the denominator is there, treated the denominator as it is. Here in the formula, v as it is, vu dash means numerator differentiation. What is numerator here? Cos x. So cos x differentiation is minus sin x. What is there in the formula? Minus. Minus I have kept u as it is. U means numerator as it is. Cos x as it is here. D by dx of denominator, that is v dash. So what is the denominator here? Log x. Differentiation of log x is 1 by x. Whole divided by v square. V square means denominator square. What is denominator here? Log x square. So after that I simplified the terms, taking LCM and taken into the outside. Minus sign common. Minus sign is common, both becomes plus. I hope you got the points here. So we are going to the last problem of this exercise. Nothing but the cos of log x plus e raised to x. Last problem. Cos of log x plus e raised to x, where x is greater than 0 again. So again, whatever the function is there, treat that function as a y. So y equal to what we are getting? Cos of log x plus e raised to x we are having. So differentiate this one, dy by dx equal to. cos of this function we are having. So whatever the function there in the bracket, you take that, assume that as a x. So cos of x is nothing but minus sin x. In place of x, what we are having? Log x plus e raised to x we are having. Now if x is there, here only it will end, but it is not x. So again we have to differentiate this entire thing. D by dx of log x plus e raised to x. So what we are having now? Minus sine of log x plus e raised to x into differentiation of log x is 1 by x plus differentiation of e raised to x is e raised to x we are having. I hope you are getting the points here. Cos of log x plus e raised to x is there. I assumed whatever the function there in the bracket I taken as an x. So differentiation of cos x is minus sin x, minus sin x is there. In place of x, what we have assumed? Log x plus e raised to x. So if x is there, here only it will end. But it is not x. So we have to differentiate further. Differentiation of this entire function. Right? So remaining same. Differentiation of log x is 1 by x. Differentiation of x is e raised to x. So again simplify now by multiplying everything to this first function into this first function. What you are having then? Minus sine of log x plus e raised to x whole divided by x. Next one, minus plus minus sine of log x plus e raised to x into e raised to x. So here is the answer for this question, dy by dx. So you can take a minus common outside and you can write a plus also. That is also fine thing. Alright. So this is a problem number 10. I hope you get all the problems regarding this exercise. So if you have any queries and doubt, please comment below. So if you are finding in some queries or doubts regarding this, just go through the video once. You are definitely going to understand whatever there in the concept. So if any doubts and queries, please comment below. Stay home, stay safe. Thanks for watching. Thank you.